Okay, now we'll talk about increasing versus decreasing functions. And so now we're talking about this graph. It has a bunch of different sections. We just want to know where or when this function is increasing or decreasing. And this is so important because we need to read this in a very similar direction. We read increasing, decreasing from left to right. And so this is going to be very much reading the action of the graph. What is it doing? Okay, its action as I read it from left to right. So before I even start talking about where that is, let's actually start reading it. Let's start all the way left, as far left as we can go. Negative infinity is our furthest left, and let's start reading to the right. As we go to the right, we come across our first section on the graph down here. And what's happening to the graph? I'm going to think about its action. The graph is going down. That tells me that the graph is going to be decreasing. Let me actually put that in red. Our graph is decreasing. Now I know we have an asymptote here. We skip over it. We go to the next section of graph and we start on the left again. And that section of graph at the start is also decreasing until right there. Then what happens at the bottom of that graph? It starts going up. It starts increasing again. So even though both of those arrows are pointing up, that's not how we read a graph. We read it from left to right and from left to right. Really what the graph is doing as we work from left to right. So on this last section, as we work from left to right, that is also increasing. I'm going to put a positive in there. Okay, now let's start. I have my colors annotated here, decreasing and increasing associated in each one. So how do I really describe this part of the graph right here? We're not using points. Again, we're going to use interval notation. We're going to use the first x to the second x, or the start to the end of that section in terms of left to right. Okay, so let's look. Section, what does that line up with? I don't know, let's say -0.4. Ideally, you won't have decimals, but it's possible from time to time. And that goes all the way to the right, but then stops when it hits that asymptote, which is at 1. So the first section of graph is increasing between -0.4 and 1. Now we're going to put a U here because we're going to join it with another section of the graph, which is down here. And if I read from left to right, remember that's going up. So we're going to use our asymptote as the start of 1. And infinity because we're using just the x values to describe that. Right? So decreasing, we're looking for where it goes down from left to right. That's this first section. It's going to start at -infinity all the way to its asymptote -2. We skip over that asymptote and go to the next section of the graph. And we're going to use the asymptote as our start on the next part, -2, all the way up until, well, where does it get to the bottom? I'll use the same value as before, -0.4. And so some keys here is not just my annotations, but how did I get those? I had to read this graph, and I had to read it in a very particular way. From left to right as I would read anything. And I was thinking about the action of that graph. What was it doing? And then, of course, how would I describe that action? I'm using just the x values, right, of each particular one of those. So -0.4 to 1, -0.4 to +1. That must have been an increasing portion of my graph, right? Yes. And so keep this in mind in terms of increasing, decreasing, et cetera, et cetera.